So we are going to explain the homework that the teacher delivered us. Is a system with 3 generators and impedances in per unit, and we need to consider the current of before the fault and the subtraction current. So the first thing that we need is rewrite the equivalent circuit. Is this with the 3 generators? We assume for the voltage value 1 with an angle of 0. The impedances 0.1, 0.2, 0.3, 0.4, 0.5 and 0.6 in per unit.
And therefore, with mesh analysis, we did our meshes in the circuit, and we calculate I1 and I2 before default, and we obtained that the value of I2 and I1 are 0.
So, as my partner said, if I1 and I2 are 0, the voltage, the pre-fault voltage is 1 with an angle of 0. Then we are going to analyze this circuit that is after the fault. So if we did the equivalent, the Thevenin equivalent, we are going to turn out the voltages sources.
First, if we turn off the first voltage source, we see that we have BF. Due to that, we know that BF only occurs before the fault. So that's why IB prime is equal to 0.
Then, in this case, IB is different of 0.
As we said, IB is different of 0, so we need to calculate that current. For calculate that current, we need to get the equivalent Thevenin circuit, and forget the equivalent Thevenin circuit, we need to get the equivalent impedance. So we turn off the voltage sources to get the equivalent impedance. As we saw in the image, we do that, and then we get the value of the equivalent Thevenin with the voltage source of 1 angle of 0 and the equivalent impedance that is 0.086 in per unit. Finally, the current is the voltage over the impedance, and we get the current in per unit, the subtraction current in per unit. So the next step is to get that current, but not in per unit, the real value, the real subtraction current. So we're using a base of 15 kilovolts for voltage base, and for SB we assume 100 MVAs. So as we see, we get the real equivalent impedance, and with that equivalent impedance real, we calculate the current. The next step was to get each value of the impedances in the real value, not the per unit value. That because in the simulation we are going to use it. So finally, the next step is we did the simulation in Tina. For the simulation was very easy. The only thing that we need to do is draw the circuit with the 3 voltage sources, and the impedances with the value in per unit. We did this first simulation, and we put an ampermeter to measure the current that flows into the resistance R1. We consider a very low value of a resistance to get the current in polar form with a magnitude and with an angle. Then, as we can see on the results, we get 11.59 ampere with a negative angle of 90. That was the result that we get in the first circuit. So finally, the next step was to do the same circuit, but now with the different voltage sources, with the base that we get that was 15 kilovolts. We did that because we need to consider now the real current, the real fault current, and the subtraction current, and that value depends on the real base voltage and the real impedances. So we did the same circuit, but now with the real value of the voltage sources and with the real value of the impedances, because in the previous circuit we consider the system in per unit. In this we unitize the system, and finally we get the subtraction current. As we can see, is the same current that we calculate before.